All right, so hi everyone. My name's Nathan Sullivan. I work for Kickstarter Australia. And yeah, I'm a DevOps engineer. So who here has heard of the term DevOps before? Hands up. Quarter of the room. Okay, cool. Not too many. Apart from the description. Yeah, cool. Okay. First things first, I throw up a little disclaimer, nothing too much of it. It's, yeah, personal presentation, not really reflecting my employer. It's fine, cool. So, yeah, what is DevOps? The term DevOps can be used in quite a few different ways, but effectively treated as the glue between software development and developers and any kind of live game operations. And when I say live game, usually a game that has some kind of server-side component that needs to always be online 24 hours a day, and in the event it goes down, someone's got to deal with it. So those type of people you generally have sort of put in that operations category. Sometimes they're known as systems administrators. Their terminology changes every year. So in comparison to I guess the model of say a few years back with consoles and whatever else, and even still today, a lot of games would have been developed, box product. You'd probably iterate internally. You wouldn't have a lot of public iteration cycles, and you probably might not even have a server-side component. Nowadays, that's changed a lot. In terms of how much DevOps would come into play, probably not very much, because once you get a public release out on those box games, you probably got very little room to change that later on, unless you release some kind of patch or distribute something. So the approach can still work internally. When you're doing what's the best way to put it? Internal iteration cycles. So once, twice a week, even once a day or whatever else, depending on how long your development cycle is on the game you're working on. So I probably should have reordered this slightly. It applies more to games with an online presence. So any game with an online presence would mean that it could be anything from a game that's everything is client-side and there's maybe some kind of central account management, and a user does something in their game. If it's a free-to-play, they could manage what they're paying for. It could be client authoritative, or it could be completely the other way, where it's a very basic client and all the actual operations are happening on some server. And there's either API calls or some kind of persistent TCP connection being maintained to one or more servers that are telling the user what they're doing. And there's pros and cons to both approaches, but I guess you've effectively got two sides of some types of games there. You've got your client side, which will involve all your graphics and all your logic, and then you've got the actual servers. And servers can be very basic. They can be very, very complex. It just depends on the game and what you're trying to do. So DevOps tends to come into play a lot more with games with an online presence. And as you know, getting something out the door and iterating on it over time is better than not shipping. So you could spend 2 years and not ship anything. You waste a lot of time. So responsibilities of DevOps. So a DevOps role could encompass one of these. It could encompass all of these. It could be more than all of these. What are the types of things we've got here? So build and deployment processes. Most developers would know how to build their application already. They probably do some kind of local testing. You build your application. Depending on how big your game is, your build process might get quite large. Sometimes DevOps can be involved in streamlining that process depending on what you're actually doing. What other types of things? Okay, so managing servers is probably a far more primary role. I would find that DevOps as a term is used more commonly with users with Linux-based servers than Windows ones. You do get people working in the DevOps field that work on Windows, but just with the percentage of servers these days that are Linux, it's just far more common. It's your traditional systems administrator role. So being a Linux guru, knowing all the ins and outs of the operating system, package management, what you install, where to make something work. Sometimes a lot of people that actually know what they're doing, at least the people that I know, tend to have just picked it up themselves over time. done it as a hobby as a teenager, picked it up, 5, 10 years later, they've learned a lot of the ins and outs. So one of the key requirements of managing those servers is if you've got a 24-hour, 24/7 online presence, if something goes wrong on those servers, someone's got to wake up and deal with it in a lot of scenarios. And it's quite commonly a DevOps person that will be, that first call. Past that, somewhat.
Do that often?
I've been lucky. In my previous role, which was not in gaming, it was worse. But I think it also depends on code quality, and it depends on how much reliance a game has on those servers. Sometimes you can even have games which, if the server component is down, they'll fall back to a sort of a local mode, I guess. It just depends on how much of the game is client-side authoritative versus server-side. So, but yeah, it's in the scenario that something goes down, a DevOps, someone in a DevOps role would normally not handle all aspects. You'd sort of be a jack of all trades, master of none. So you would know at least high level what talks to what, how everything works. But past that, once you know, okay, it's a particular aspect of the application, you'll usually find a subject matter expert like a developer or something like that and go, hey, look, this is broken. What should we do to fix it? So it's more frontline. That's only one component. If you design everything right, it is possible to not have to wake up in outage scenarios. But it takes some time to get there. So making applications and systems that are self-healing get interesting, but not impossible. So what else have we got? Provisioning and decommissioning servers. So up until a couple of years ago, that would have been, could have been going to a data center provider, getting a, saying we need 5 of these servers to do some specific task, get the servers together, get the operating systems installed, get all the software on them that you need to, and then say, okay, cool, development team, we've got some servers here to run your application on now. That can sometimes take, depending on how your workflow is of getting those servers, it can take anywhere from a couple of days to a couple of weeks. Nowadays, now that we've got various cloud providers, Amazon Web Services, Google Compute, you've got, you can do that in hours or minutes. And so a lot of my task these days is doing whatever I can to allow us to work faster. So that would involve, if we need servers, being able to get them quicker when we need them. If we're developing features on a particular application or game, and if you've got a larger development studio and you've got a portion of the team working on different parts of the game, and they're like, oh, well, we need to get some servers up to test this. If you've got physical servers, it would be, you'd either be rationing your environments that you can put these on, or sometimes you'd have environments sitting there doing nothing and you're paying for them. At least if you do things correctly with a cloud provider, you can go, well, cool, we've got 5 different features being worked on here. Let's spin up 5 environments and work on them. Iterate, test them, do what you got to do. Someone finishes, spin them down. And the advantage with those cloud providers is they're mostly pay by the hour models rather than pay by the month models for their servers. And you can spin up as 1 or more, or you can spin up as many as you need effectively. So you've then got companies like, as opposed to what you would traditionally call infrastructure as a service, which would be your Amazon, EC2, who else there? Yeah, Google Compute, DigitalOcean, there's a handful of others. You've also got what you would call platform as a service providers, which would be Google App Engine, Heroku, a few others, where you don't actually get full access to the servers. You just get, you upload your application and then they put them on some kind of server and expose them to the world for you. So it depends on how, which model you take on as to how you're administering them. But at the end of the day, someone's putting some kind of tools together to let developers actually get their application onto those servers. So, yeah.
Would platform as a service be more appropriate to smaller developers?
Yeah. It would apply, smaller developers, definitely. You normally integrate with them with either some kind of API or a web interface. The downside is you don't get a lot of control, and you're normally limited on what languages you can run on those platforms. So they may provide very specific, like that. They'll normally do all the web programming languages. They'll do they'll do your ASP.NET, they'll do PHP, they'll do Python, Ruby, stuff like that. Sometimes they'll run Java-based applications as well, but then you go and say to them, we want to run some custom C++ server binary, you might struggle. That's where going through, like an infrastructure provider where they give you root access to a server. You can go and install anything you need on it, run whatever you need on it. So, each has their benefits, and the billing models do differ between them as well. The platform as a service is cheaper initially. As you start to get scale, the infrastructure as a service, if you're creative with it, can probably either equal or better it. Platform as a service is normally designed where if you start an application from day one, you don't want to think about the servers. You pretty much just upload your application there and they deal with the scaling aspect. But you do have to develop your application around their constraints about how you connect. A lot of them will be limited to either HTTP only. Some of them will allow TCP, direct TCP connections. If you needed UDP traffic, you might struggle with some. It just depends on the platform and what they're actually providing. So the lower down the stack that you go in terms of operating system control, the more flexibility you'll gain. So at the expense of management, time. So and I guess one of the core goal is supporting developers in their what their requirements are and to reach their goals. So okay. So in terms of DevOps structures, I've been a DevOps engineer at Kixeye for about 12 months. Before that, I was working for a voice provider, designing their voice network. I would almost have, even though I didn't have an official title of DevOps, you could have almost called my role a DevOps role. I was managing servers, I was spinning them up, I was getting application code onto them, I was, effectively making sure they're always running, working out what's the best architecture of, should we go virtual servers, physical servers, et cetera, et cetera. So, it doesn't just apply to games, but at least in the last 12 months, I've seen a few different organizational structures. A small development operation, 1, 2, 3 people. Chances are one of those people is going to be forced to go and learn the skills that they need to get their application on a server somewhere. They'll grow a little bit bigger. They'll want to focus more time on development and then realize, well, maybe we should just make this someone else's problem and hire a DevOps engineer. There's no real clear threshold. It really just depends on time of the day.
Idea of size. How big is Kixeye? How many people do you have?
So Kixeye, as my employer currently, we have, I think it's around the 500 staff worldwide. Our office here in Brisbane is about 40 staff. Just over 40 staff. 90% of those staff are specific to the local studio developing a single game. So they're an autonomous operation, semi-autonomous operation. The other 10% of those staff are actually a central operations team that is used to, which I'm not a part of. I'm actually part of the studio, but their focus is all the games within the company, and that encompasses all of the overseas offices and everything like that. And they actually operate a 24/5 rotation. So they have United States, Australia, and Europe as in terms of staff, and they do handovers and everything like that. So they're very traditional operations as opposed to DevOps, which is a bit of a mix. So when I first started at Kixeye, I actually reported to the central operations structure. DevOps was not embedded in studios. It can work well in terms of knowledge sharing, but it can make life difficult in terms of reporting structures. I effectively had 2 bosses. I had a studio which was my customer, and I was, that single studio was my customer. But at the same time, I reported back to a central structure which their priorities didn't necessarily reflect the priorities of the studio that was my customer. So it was interesting. After that, they opted to change things and embed all the DevOps members in each studio and just keep a more lean central team, which does work. The key then becomes division of labour, what parts of the role are dealt with by the people within the studio and what parts are dealt with by the central team. And that's a never-ending fight. But we manage. Usually it's whoever gets to it first. So yeah, if I need something done and I make a suggestion to them, they'll throw out a suggestion of a way to do it that will benefit both teams, multiple teams. If I get to it first, I'll do it from the studio that I'm focused on. If they get to it first, they'll do a more shared approach. But just depends on the day and what the task at hand is. So yeah, so as you can see, yeah, single studio, which is not necessarily our organisation, but a smaller version of our organisation with one studio. You'd probably have one person, maybe part of their role or their entire role would just be dealing with DevOps. And yeah, multiple studios, you can do the central operations arrangement. A perfect example would be if we were ordering physical servers, rather than me going and dealing with all the back-forward communications with server vendors, dealing with getting the base operating systems on them, which is pretty standard stuff, isn't specific to one game, we just delegate that to the central team. They've got a couple of people, they know how it's done the same way every time, and they just hand it over to us when it's ready, and we go and make it specific to what our game requires. That's why, yeah, it can take some time. Nowadays with the use of cloud providers, I've spent probably the past 6 months of my time focused on developing our application to run on Amazon Web Services. So I have almost completely detached ourselves from requiring the central operations team. But they're still there. The one benefit that they still provide is a 24/5 front line in the event of outages. So they can look quickly. If it's something simple, they can fix it and don't even wake me up. If they can't, they'll wake me up. I'll look at it. If it's something I can fix, I'll do it with at least some expertise of the game that I'm tasked to. And then if not, I can raise it to developers and wake them up, and I can raise the alarm bells. So
are you geared up to work from home, or do you have to go into the office to do it?
I can work from a train, and I do regularly work from the train. Yeah, I can work from home. I could work right here, right now. My mobile phone with 3G tethering and a laptop is all I need, and a headset to be able to have Skype calls or Google Hangout calls. That's about the only requirement I have. Yep.
So internationally, you gain more cloud-based providers, or rather than infrastructure?
Yeah, so our company focus, at least since late last year, has been primarily for cost reasons, to move as much as we can to cloud providers. The gains that you can get from, I guess the time not wasted waiting for physical servers to be provisioned, and then getting operating systems on them and then handing them over, the amount of time lost and productivity lost there, combined with the fact that you might only need them for 2 weeks. If it takes 2 weeks to provision it, why order it? And then sometimes there's contract terms on those of minimum 1 month, minimum 3 months. So it hurts productivity-wise. Whereas cloud providers, you spin them up, like I spin up servers in minutes, and when people are finished with them, I spin them down in minutes. One of the interesting workflows that if you can get things quick enough, you can actually spin them up in the morning, work on them, and spin them down before you leave at night and only pay for 8 hours of the day out of 24 hours in the day. So you've just made your cost 30% of what they would normally, and you take weekends out of the equation. So you need to have your process very streamlined to do it, because the worst thing is if you get in the morning and you waste an hour out of every day just getting to a point that you can start iterating on your code, is it really worth it? But if that's 10 minutes, different story. So.
Does Kickstarter still have much physical infrastructure then, of their own?
Yes, a lot.
Is the intention to move all that to the cloud eventually?
Yes, as much as we possibly can.
Are they looking at making it are they operating it like a private cloud?
A combination of both. Before our Amazon Web Services use, there was some talk of doing a private cloud, take some physical servers from a vendor, set up something like OpenStack or one of the other virtualization stacks on top, and then provision virtual servers off that. Yeah. Certain workloads, that makes perfect sense. Things that don't scale very much and things that are going to be pretty static and always need to be online, yeah, that makes perfect sense. Things like HR and IT systems, like authentication systems, anything like that that is infrastructure that's used to manage other stuff, makes perfect sense. If you've got games that can have peaks and lows in terms of what they use in resources and servers, with people like Amazon and Google or whatever, you can actually auto-scale and bring up servers during different peak times a day and spin them down at other times a day, and you can follow the demand curve. And if you're paying by the hour, they can make big differences. So Yeah, it's a combination of both at the moment. Ideally, we would try and move everything to cloud providers, primarily Amazon at this point. But since then, I've seen Google Compute has been trying to compete very, very heavily. I think it was 2 or 3 months ago. Google dropped their prices by about 40%, and then a week later, Amazon matched them.
Azure even lower again,
Yeah, so Azure, I guess, is they're very targeted on Windows, but you can still run Linux machines on them, obviously. But I think if you had a Windows-based server environment, you would be silly to discount Azure. You'd have to consider it.
Microsoft have really bent over backwards recently.
They have.
To open it up.
They're trying to get as many different regions or data centers that you can provide services out of, because you want to have as many as you can. Like with Amazon, you've got 8 public regions right now. 3 in the US, 1 in South America, 1 in Europe, and 2 in Asia, 1 in Sydney. So when you can pick out of those 8 where you want to run your servers and spin them up in minutes, compared to anything else, it's a big difference.
Microsoft don't really do anything other than Azure services in Australia.
That's right. Yeah. I guess the benefits with Azure is if they can move a lot of their legacy infrastructure over to something that they can, things like the old Hotmail, mail services they used to run and everything, they can run those all inside the same infrastructure that they sell to customers as Azure. There's going to be cost benefits internally for them. But at the same time, they're competing with the likes of Amazon, Google, and everyone else. So you've also got sort of more second-tier players that are really trying to make a dent in the market. But they're not as well known, but they have some pretty competitive pricing. A lot of the keys with these cloud providers is their APIs and the maturity of their APIs. If you have to do something through a web interface, and that's the only way to do it, then it's going to be difficult to really get your workflow up to a speed that you can, do things quickly. If you've got an API, you can use the infrastructure as code mentality, where you basically everything that you want to do to spin that infrastructure up is written inside some kind of script or some kind of code, and then you just interface with their APIs to bring them up and tear them down. So, yeah, that's high level. But yeah, I'd say there's almost a whole talk just in cloud providers and how they work and how to use them well, which is interesting. So I won't go into heaps of detail, but feel free to talk to me afterwards. I'm happy to talk about that. So yeah, in terms of the tools that I would use on an average day, I would say at least half that list I would be touching on an average day. Bash and Ruby are probably the most common scripting languages that I'll use to do whatever I need. Puppet as well is probably one of the primary ones that I use as well, and I'll go into detail on all of these specifically next. And then so then you've got build management software. Some of you may heard of these systems. There are others as well. So yeah, you've got Jenkins, you've got Bamboo. There's others such as TeamCity. I was going through when we were considering what build software to use, and there's probably 10 or so that come to mind that are worth considering if you're assessing your options. But these are the 2 big ones. We previously used Jenkins, and we're actually trying to move ourselves to Bamboo currently at Kickside. So there's reasons for each, and I will go into those. The automation tools are probably one of the areas that are very much my domain within our company. So as I said before, infrastructure as code. So previously, the way you might bring up servers is you would bring one up, you would install some packages, you would make the server look like what you need to, and then you might build an image of it and call it a template. You can actually do that a different way and programmatically describe what the server should look like, and then take a vanilla operating system image off the shelf, whether it's Linux, Windows, anything, and then programmatically script what needs to be installed and what needs to be done on that server, and then it spits out an image at the end.
Wouldn't that be a problem? Versions of things change, your scripts.
You can version your images. You can version your images. So just like you could version your builds of your application, you can version your images. And then you can, obviously, all of the code that you use and the scripts that you use to build that server, you can have in version control. So, and if someone says, oh, we need a new version of this particular piece of software, let's say you're on a Linux system and you use a package manager that, let's just take Ubuntu server, for example. You go in, there's a package manager called apt. You go apt-get install some package. Let's say it's Java. Then someone says, oh, we want to install a different version of Java. Now, it's quite common knowledge that some package managers are better than others at cleaning up their mess. So if you install a package and then you say, I want to install a different one, and you uninstall the old one and then install a new one, you hopefully think, you hope that it's removed all its mess. Or a better way would be to start again with a vanilla image and then you just provide a different version number in the script and it just builds one from clean slate every time. So it's a workflow shift from what people are used to, but and it does take a little bit of time to get to a point that you can use it well. But once you do, it's very, very handy. Yeah,
So just as in terms of you were talking about your provisioning time before.
Yep.
When you're using that approach, will you usually stick with using that exclusively, or will you like run the script then make an image so that you can boot up faster, or do you find that it's actually, because I know that
You're talking ahead of time versus just in time in terms of actually installing the packages inside that image?
Because I imagine the trade-off is probably between images are usually specific to a data center, aren't they? So you can do anywhere with the script. Right?
Slightly different. Data center, as well as what the role of the server is going to be. Like, let's say you've got different pieces of your application that have different software dependencies. You might have a different role. Like one might be a database server, one might be a web server, one might be a caching server. Each of those has different software dependencies. So yeah, and then in different data centers, you'll have different networking configurations and host names and things like that. So usually I just try and build, I guess, what's the best way to reflect it? A matrix of different configurations, and I build an image for each. And the tools I use can build them all in parallel, all at once off the same scripts. So, and, yeah, I'll go into some detail on that, which is, yeah, quite handy. So yeah, Vagrant, Packer, and Docker. Vagrant and Packer I use very, very heavily. I will go into what you said about trade-off as well between the ahead of time versus just in time. Docker is something a little bit newer. I will touch on it, but it's not something I've used heavily. So, so yeah, okay. Anyway, to go back to languages. So, yeah, Bash. What percentage of you are primarily Windows users? Okay, cool. I assume some of you would have heard of PowerShell. Okay, so Bash is effectively the non-Windows equivalent of PowerShell. I think PowerShell exists because Microsoft realized that Bash was everywhere and they needed something else that could do what Bash would do. Hence, you have PowerShell. Bash has been around for probably decades. It's a scripting language that's available on everything Mac, everything Linux. Then you've got all your BSD equivalents and things like that. If you have low-level enough access to an Android device, you probably will find Bash is installed and you can run Bash scripts on them. So yeah, any Linux-based machine will almost always have Bash. The init systems that actually started initial processes up until recently were almost all written in Bash. So you couldn't run a system without it. So yeah.
Presumably it's easy to install Bash. Like I've seen a couple of different
So on Windows,
Bash-like things.
Yeah. So yeah, you've got Cygwin, and there's another one I think it's called MinGW or MingW or whatever they call it. But effectively they provide like a subset of the Linux, wildcard Nix world tool sets to run on Windows. And they just come as an exe, and you just go and install it, and you get a little like a shell, and the shell you can just run Bash scripts in it.
I installed Git for Windows, and it came with Bash.
Yep.
Is it the full Bash?
That's probably the full Bash as a dependency. Yeah, I wouldn't be surprised. But yeah, Git was obviously designed specifically around the Linux kernel initially, and then it expanded past that. Or, well, I haven't checked the workflow, but I know one of the primary users of Git was when BitKeeper tried to hold the Linux kernel developers at ransom for licensing costs, and the Linux guys said, no, we'll develop our own, and you have Git. So,
interestingly enough, Microsoft are actually, I guess, increasing the use of their PowerShell. They're actually getting away from a lot of the GUI interfaces.
Yeah, that makes sense. They've realised that the programmatic approach can really have big gains.
And PowerShell is extremely useful when you've got cloud-based providers.
Yes, Definitely, yeah. So some of the tools that I use that I mentioned here, such as Vagrant, specifically Packer, has the ability to run PowerShell scripts. I will go into that shortly. But yeah, Bash is obviously anything non-Windows. Well, you can almost guarantee it'll have Bash. So if you need some portable script that you can take around, there's a good chance if you run it in Bash, you can run it everywhere. So that could be simple scripts such as stopping a service, starting a service, copying some files here, any common task. Yeah. Yeah, one of the downsides of Bash is that it's not a solution to all problems. I've had quite a few scripts that they've ended up a couple of hundred lines. They won't necessarily be structured code. It's pretty much all functional or procedural. There's very little object usage, I guess. You do have variables, you have different variable types, but you've got regular expressions, but only in the latest version of Bash, which isn't available everywhere by default, do you have half-usable arrays. But past that, like string manipulation, a lot of the time was actually call another executable on the system to do the string manipulation and then return it back to the Bash script. And you'll find a lot of Bash scripts rely on other tools on the system to actually complete their jobs. So, but yeah, at the same time, you can find yourself doing 20 or 30 lines of code for something that would take 2 lines in a language with basic language construct capabilities. So yeah, and I have quite a few times gone, I need to bite the bullet and port this from Bash to Ruby or Python or something else just because I needed, useful hash tables or something like that just to be able to store data and iterate over it and do things with it. So Ruby is my personal language of choice. The reason I initially opted to learn Ruby was one of the tools that I listed above called Vagrant. Vagrant, you can specify certain virtual machine configurations, which I will go into, but all of the logic is written in Ruby. So I was forced to learn Ruby out of necessity there. And then from there, I've just started writing as much as I can in Ruby. It's easily installed on most platforms. It does provide functional as well as object-oriented capabilities. It's got threads. And yeah, so since then, Ruby's been, I guess, sort of one of my primary tools on an average day. One interesting thing is the multiple interpreters. So MRI is the standard, or they call it CRuby. It's the standard interpreter for Ruby. It'd just be like if you've got a Java application, you've got a JRE or a JDK and there are multiple. There's the Oracle one. There's the you've got the what is it? There's is it ICE-T? I think it is. There's a couple of them. There's a few different variations of JREs that you can run different Java applications. Just the same, Ruby can do it. And there's also JRuby. JRuby can run Ruby code inside a JVM. So, and you can actually include, what was that?
Why would you want to do that?
You can include standard Java classes and libraries and use them within your code. And one of the problems with MRI is it has a global interpreter lock. So even though you can use threads, you can't use more than one entire CPU core. So it's really good if you've got multiple tasks waiting on external responses, but it's not very good if you're trying to get maximum grunt out of a single machine. JRuby, on the other hand, will use all the cores on the system at the expense of having to deal with the likes of garbage collection cycles and anything else that comes with Java. So Rubinius is another interesting interpreter that I've started using it. I think they've tried to take the best of both worlds. There's no global interpreter lock. They've got a set of like 60,000 tests against the Ruby spec to make sure they have language compatibility. But I think they've rewritten all the core components in C. That all the stuff that needed higher performance, and by removing the global interpreter lock, you can, Rubinius is quite powerful. The problem is it's not quite as, it's not perfect when you try and take off-the-shelf Ruby and run it under Rubinius. Everyone will test for MRI, they won't always test for JRuby or Rubinius. JRuby is probably more common. People will test for MRI and JRuby. And you'll find, there'll be public gems, which I've put there, which is effectively your repository of pre-written code that you can just go gem install this. There's a web search engine. You want to do some tasks, such as one of the ones I use very commonly is interacting with various cloud APIs. There's a library called Fog, and Fog goes and it can talk to Amazon, Google, and about 10 or 15 others, all using the same language constructs. And so you can just change the provider when you instantiate the object, and it'll just talk to the other provider's API, and you just change the credentials. So you could write an application using Fog that can talk. You focus on one cloud provider, but then let's say another cloud provider comes in at half the price later, or they've got something that you can't get on Amazon, for example. You just go and change your provider. Just point your code, and away it goes. So rather than rewriting your whole application, which would have been focused around one vendor's tool chain or tool set. So some other gems that I use. I needed to perform exponential backoff of API calls due to request per second limits on certain public APIs. There's a gem that I can use just to wrap the code I need to do and say, okay, if I get this exception, retry it up to this many times and back off 2 seconds the first time, back off 4 seconds the next time, back off 8 seconds the next time. So it'll exponentially back off and stop hounding the cloud provider for a response to their APIs. So that's just one of thousands and thousands of gems that you've got, and they're usually all very small, self-contained libraries that they'll do some specific task. If there's something you need to do, chances are someone's written a gem for it already. There is the equivalent in the next language I was going to mention. I think there's a tool they use called pip, but there's actually an index. I can't remember the exact name of the index, but it's effectively got the same as gems. You've got little self-contained modules that can do all kinds of different stuff. So. And it's just a single repository for all of it. So Python, just as common. There's always a little war between operations people about Python versus Ruby.
What about JavaScript and Node.js? Does anyone use those in DevOps?
It's not as common in DevOps, but I'm seeing more and more server-side development actually being done using Node.js. But you'll find all the server-side configuration management tools are still usually either Ruby or Python or Bash. I haven't seen many tools that are written like CLI tools that would be.
Do you think they're really going to
100% JavaScript?
Node seems really popular.
It seems really popular. I guess Node was designed with the purpose of handling incoming requests, and I haven't looked at the internal architecture. It does do some kind of threading model internally. I think I haven't looked at it. I know there's other parts of our company using Node.js, but I don't use it myself.
It's all meant to be single-threaded. I think you can get around it.
Is it like a single event loop or something?
So it's all...
You can run multiple processes each with a different virtual machine.
Yeah.
It does that very efficiently.
Yeah.
It's meant to be very efficient for asynchronous single-threaded work.
Yep.
But handling lots of requests, just asynchronously.
Yes.
On one thread.
Yep. That makes sense. Yeah. Especially handling web requests, I've heard. It makes a lot of sense, especially if you can write client-side code and server-side code in the one language, JavaScript. Node.js being based on V8, you're kind of getting the equivalent JavaScript performance as Chrome, so as a browser. So you're probably not going to get much better than that. But it's I haven't found many CLI tools these days that are written in Node.js. That may change, but I was having a look a couple of weeks back on GitHub at the language, I guess what's the way to word it? The breakdown of different language popularity. That's right. And Python was staying level but slightly dropping off. Ruby was actually dropping off quite a bit, and JavaScript was going up, which would tell me there's a lot of people probably using Node.js. Either client-side JavaScript or Node.js based applications, but I haven't come across many tools that I use on a day-to-day basis that are JS based yet. So you'll find almost everything you can do in Ruby. You can probably do it in Python as well. I think if I'm correct, Python was around before Ruby by quite a few years. But it since then, I guess there was a lot of people that jumped and started using Ruby. A lot of people that stuck to Python. I still find some tasks are easier in one, some tasks are easier in the other. I do most of my stuff in Ruby. Amazon's official CLI tools. They have they have two variants, and one of them is Python based. I think the other one might have been Ruby. I can't remember. There's definitely two of them. But yeah, it's each to their own really these days. I think it's almost it's probably a 60-40 split of within people that have some kind of operations role within our company that actually use Python versus Ruby. It's probably 40% Ruby, about 60% Python. But that changes all the time as you get staff attrition. So that has been over 50% on Ruby in the past. So, so configuration management. Configuration management's an interesting topic. It effectively comes down to making a given server or machine conform to a set of specifications. So you take a vanilla operating system and you know that you're going to need these 5 packages installed of this version, you're going to need these files in this location with this contents. You could either write a little bash script that does it all for you, or you could use some kind of configuration management software to do it all in a way that's clean. The benefits of doing it with some kind of a configuration management tool would be they normally are all designed to be idempotent so that you can run them as many times as you want. If there's no action to be taken, no action will be taken. With a bash script, you have to go and write that logic for every operation. If this has already been done, don't do it. Else, do it again. So yeah, you're double handling a bit if you try and do this stuff in bash. It's not to say you can't do it, it's just, for very small projects, bash is sometimes easier, but you'll quickly grow out of it when you realize you've got 50 packages you need to install, you need to manage the versions and the dependencies of them, you need to manage all kinds of operating system level configuration, and then you get to the point where you need to deal with users and SSH access for those users, and you've got to manage how they can get into their systems. Using a configuration management tool starts to make life a lot easier. So, primary things it does: install packages, manage configuration files. How you execute it is an interesting one. When I first started using most configuration management tools, the accepted way to do it was to rerun the tool every half an hour or every hour, just to ensure that every machine always conforms with a set of rules. If there's ever something that changes, like a security exploit, and you need to upgrade a package, I'll throw out the example of OpenSSL. On every system, you just go in, change the version, and then an hour later they've all been upgraded. And the different software can also have things like dependencies where it can understand what a file is, it can understand what a package is, and it can understand what a service is. So let's say you've got a web server like Apache or Nginx. You've got the package that's installed for those. You've got the virtual hosts or the configuration for those that web server. And then you've got the service itself, which is involving starting or stopping the web server. You can have it where if the configuration changes, it notifies the service to restart. But if there were no configuration changes, don't restart the service. So that's an example of where you can get a little bit more intelligence in these configuration management tools. So since we've changed our use case a little bit in the past probably 12 months, I've opted to move to more of an event-based call rather than executing the agent that goes and ensures that system conforms on a given machine. Rather than doing it on a time base, I just do it when something needs to change. So I'll fire some event out to all the machines and say, something's changed, you need to go and run your configuration management tool. And it just kicks off an execution. When I'm setting up machines on cloud providers, that will be initially on system startup, I'll run that. At least once, sometimes twice. The other time will be if I've got like some kind of service discovery mechanism, where if certain servers come into a cluster or an environment and other servers need to know about them, they can rerun their configuration management tool to update local configuration files to say there's another one of this server in the pool now, you can start using it. An example would be a load balancer configuration or some kind of messaging queue that, an extra node was added to a messaging queue cluster, such as say RabbitMQ or ActiveMQ or something like that. You could update the configuration file and then restart all the services or reload the services preferably to so that it's introduced, I guess, in a non-destructive way. So by doing that, there's no point in wasting CPU cycles every half an hour if I don't need to. Just do it when I need to do it. So Puppet, is the tool that I currently prefer. It's, you declare resources effectively within Puppet. So you'll declare a file, you'll declare a service, you'll declare a package. Within any of those types of things, you can have parameters. So with a package, you can say ensure that the package is present. I don't care what version it is. Or you can say ensure a hard version. So you can always guarantee that this version is installed. The upside to hard versioning is next time you run Puppet, if someone has changed the version of the software, it will actually try and revert it back to make sure it conforms. So and normally a Puppet run can take anywhere from 5 seconds to 5 minutes, depending on how much logic you've actually got in there.
So this actually runs on the server?
Runs on the server, yes.
But it executes the configuration you've sent it?
Depends on how you configure it. There's a few different ways to do it. You can either use, I think I actually had something in one of my slides about this. Yeah, I did. It was on my next slide. I'll talk about that in a second. Puppet has been undergoing quite active development. I'm still running 3.4 at the moment. I think it was either 3.6.0 or one of those. They actually had to revert the release and get rid of it because it had a major bug. So I at least wait until the 0.1 or the 0.2 release before I touch one of these tools. It's all Ruby DSL, so it's a form of it looks a bit like Ruby. You can do certain things in Ruby, but there's other things that are very much Puppet specific in terms of the way they declare resources. Individual resources have to have a unique name through an entire, what they call a catalog. And a catalog is built at runtime when you start the agent. So if you have two resources that have the same name, it will just error out and say conflicting resource names, can't do it. A resource name could be a path of a file. It could be a package name. It could be something else as well. It could just be an arbitrary string that you provide. And sometimes you can actually build the resource names from variables. So you can do some fun stuff once you get in there. So workflow. So you can either write your own modules, which are usually a combination of either manifests, they call them, manifests, templates, and there's another, you can either have static files as well, and then you've got internal functions or providers, they call them. Manifests and templates are probably the most key and I guess basic components of them. A manifest will contain all of your resources. So a simple manifest might be class, such and such, package, package name, ensure present. File, configuration file name, ensure present, content, or either content or source of this template name or just a string, and if you just put a string in there, it'll just put it in the file on the server. The templating approach means you can actually feed variables and parameters into these classes that will then get embedded into the files. So you can have a configuration file where it's like hostname, variable hostname, and then whatever string syntax the application requires, you can do that, and you just put variable substitution all through it. So, and you get some pretty big config files, and then you can get some really complex logics where they use concatenation of multiple files on the server, where they build pieces and then they effectively put it all together as one. It gets pretty complex. So you can write your own modules where you can just write some manifests and some templates, and occasionally I do that. The far better way to do it is to go and look on the publicly available Puppet Forge, grab preferably the better of the modules. There's sometimes 3 or 4 or 5 modules for a given task. You've usually got to go through them and look at the source code and see what the quality's like and see how much functionality they've implemented. Sometimes they'll do it pretty well, other times they'll do a really heinous job and I'll just ignore the module. There are times where I go, there's no public modules up to a standard I'm happy with, I'll just have to write my own. So, depends on what you're doing. In our average environments for the application that we work on currently at KickSci, I probably have 20 public modules that I'm using. They might vary everything from NTP, configure the NTP server for maintaining time sync, configure a web server, configure one or more database servers, configure the way I've installed Ruby. And I can install gems under different versions of Ruby. So there's a whole set of tools around that, which I won't go into at the moment. But
how many servers are you actually looking after for this particular game?
This particular game right now, across across about 10 environments, all the way from development to production. Probably 150, maybe 200, out of a total of 1,500 plus through the company, maybe 2,000 in the company.
Does that scale up and down then with the actual?
It scales up and down when I need to, really. Depends what we're doing. Like if we're load testing an application, for example.
But with the number of users that are playing the game?
Right now, it's not automatic. That's the goal we have. Right, we have a goal to get to a point where that server count will scale with the number of users online. Correct. Right now, that's not the case. It's static. So we have to over-provision effectively to handle the peaks. But the one of the keys when I first started at Kixeye, we were treating. There's a terminology in the DevOps world of treat servers like cattle, not pets. So when I first started, we treated machines like pets. We would make sure that they all had names that we knew. They all had things on them that we knew, and we knew exactly what they look like. As opposed to the cloud world, where they're like, if a machine doesn't do what it's doing, just shoot it and spin up another one. Cattle. So, nowadays when we go and say, we need to do a load test, that's all right, I'll spin up an environment of 38 or 40 servers in 7 minutes. And I'll have everything on them exactly how they need to because it's all been written programmatically. So, the advantage is I can change one thing, like say, the Java version we need to run. And I can change it in one place in one line, and then it takes me about 15 minutes to destroy the old environment, spin up a new one, and I've got it. Rather than logging into 20 machines that need 20 out of 40 machines that need Java and go and downgrade the version and upgrade the version and whatever else. So, yeah, once you start getting into scale, doing it programmatically just makes life easier. You just don't even really think about the machine state. You just
Well, it makes it possible, doesn't it? I don't know about
yeah. That's right. Yeah, when you're treating machines like pets and you don't have the tools that let you do that, treat them like cattle. It makes it hard, and you're forced to treat them like pets. So, but yeah, the mindset is really changing towards that other direction. So
there's got to be a break point somewhere in the number of servers that you've got where you can start to justify the time to produce those.
That's right. That's right. Yeah, correct.
I've been in situations like that, but we've never had enough servers.
To justify it. You just go, I'll just have to do this manually and hack it. That's right, because it would take me a few hours to do that. It'll take me 5 minutes to do this now. But if I have to do this 5-minute task 10 times over the next 6 months, then, maybe, it's worth considering doing programmatically. Yeah, so it took me quite a few months to get to this point, but now that I'm there, it's definitely a time saver. And what I was saying earlier about that workflow of being able to spin machines up in the morning and spin them down in the afternoon, when you've got a cycle where it takes you under 10 minutes to spin up the whole environment and half that to shut it down, you can consider doing that. So, yeah. In terms of, there's a few tools there that I've mentioned, Librarian, Puppet, and R10K. I use Librarian Puppet primarily. Some of our overseas officers use R10K. They have a similar goal, which is effectively you provide a Puppet file which specifies the public module names and their versions, and you say pull in all the modules, and it'll go out and find 20 or 30 Git repos and pull them all in and build a directory of modules locally. And then from that, I can execute a Puppet agent against that. So it just populates the list from public sources, and if there's a version upgrade, I just change the version file and just go repopulate. So I maintain a local copy of all the public modules, but I don't manually pull them all in. I just change the Puppet file and say which ones to pull in and what versions of them. But I do hard version them all, so if someone ever changes functionality and increases it and breaks it, at least I'm on the previous version. It's usually just a Git tag on GitHub half the time. So, Puppet agent versus Puppet apply. So one common approach with Puppet is that every machine just runs a thin agent and you tell it the host name of a Puppet master. The Puppet master contains all of the actual code that is going to be executed. So when an agent starts, it asks for a copy of what's called a catalog from the master. The server that compiles a catalog locally and then sends it back, and that catalog will contain all the resources for that given server. When that Puppet agent runs, it sends a heap of metadata about that server back to the master and tells it, this server has this host name, it has this kernel version, it has these IP addresses, it has, they're what they call facts, using a tool called Factor, which is very tightly integrated with Puppet. And so yeah, there's about 50 or 100 facts, and you can introduce your own. They all get sent up, and the value of every fact can be used in any manifest or template. So it's just available in top level scope. So I can reference that, if I've got a config file for a server and I know that whenever I run this manifest on this server, I want the IP address of the ETH0 interface to always be in that spot in that config file, I just put the variable in there and just substitutes it. So.
Let me know if I'm jumping ahead.
Yep.
So in terms of you being able to spin new servers up, and we were talking about the imaging stuff earlier,
Yep.
do you basically have like an image that has like a vanilla Linux installed, and like the one thing it does is it runs Puppet agent? And then that's how you decide, and then the master decides what the task of that machine is going to be. Right. So do you only ever create those images manually, or is that something that you do automatically?
I can do both. Right now I do them manually, but I'm going to work to a point where for CI purposes I'll just spin new copies like once a day or something. Or I could even do it where on code commit I change, I just spin up a new build of the images. Yeah. The central master approach, the problem is if you've got 1,500 servers, the master is Ruby based, and you can, it's not very efficient the way it's been written, and we've ended up having to put multiple Puppet masters behind load balancers. And it got to a point where we were spending 5-digit figures, probably 5-digit figures a year, maybe 6-digit figures a year, just on Puppet master infrastructure. Those servers don't do anything but serve out catalogs to other servers. So, which is really not necessary. The Puppet apply approach is where you have to get all of the manifests and all of the code to be executed to the server, and then you just run the agent locally and say reference a path on the server, and it just executes them all locally. And it builds a catalog locally as well. It will use slightly more CPU cycles locally, but you probably have, you've probably got 1% of your CPU cycles spare to do that. It's probably even less than that. There is merits to doing Puppet apply. The other problem with Puppet masters is they're a single point of failure. So we've had it before where we're running a Puppet master, and when it fails, no new staff or no old staff, no new staff are added and no old staff are removed from any servers, and their SSH keys to log into them, nothing changes if the Puppet masters are down. Running Puppet apply, as long as the version control system is online, you normally would go do some kind of pull of the version control on whatever basis, and then run the Puppet agent against it. The way I do it when I'm building images is when I create a new system, I send a tarball or a compressed zip or whatever of the actual Puppet code up to the server and then extract it and then execute it. I build a copy of that when I start the image creation process. So lessons learned, I probably just went through half of them just then. Not all public modules are equal. Definitely, hard version modules it is definitely something I would recommend to avoid breakage, unexpected upstream breakage. Try not to fork modules. Excuse me. You'll find most module authors are willing to accept pull requests on GitHub or something like that for improvements to their modules. So an approach I've seen many times is someone will say, oh, this module does 90% of what I want, but I want to change some little thing. So they'll just take a fork and then they'll hack in their little changes locally. Problem is, then you'll find that the upstream module will diverge and they'll add, twice the features, 6 months down the track. But then someone's got to manage rebasing those patches against their local their local copy. If you just at least have a patch that is of a sufficient quality that the upstream will accept it, send it back. It's quicker, because then you can keep using the upstream module and get any improvements that other people provide over time, which I've found many times myself. So saves a lot of work. Oh, sorry. You're right. What else is there? Yeah, Puppet aging will work well, as I said, becomes expensive, and yeah, they're single points of failure. Okay, Chef is another tool, very much like Puppet. An analogy I've heard in the past is if you put people that come from an operations background in a room and give them both tools, and people that are developers, primarily developers, put them in a room, the developers will pick Chef and the operations people will pick Puppet. It just feels that's how the tools seem to feel to them, just in terms of the way they declare resources and the way the workflow is structured. So they're both Ruby based. They provide similar functionality. It's just a matter of how you're writing that functionality. So.
How did it come about that both of these tools are in Ruby?
I have no idea. Probably pure coincidence.
The Ruby community?
I'm not actually sure. There are two other tools that I'll briefly mention that are Python based, and there's I did read yesterday that Chef has gone and made their server Erlang as of last year, probably for performance reasons. So whereas previously they were running a Ruby-based master and a Ruby-based agent, just like Puppet was. Puppet have obviously not changed theirs, but yeah. So so Ansible and Salt are both written in Python. Ansible's been around for quite a while. I haven't used it personally. Salt looks like one of the sort of new kids on the block. The downside is there's not as many public modules out there that you can go and take and use off the shelf to set up, configure a web server or configure a database server without having to think about it. Half the time you'll find there's not a module and you've got to write your own. But give it a year or two, that'll probably change. I've heard that Salt looks pretty good in terms of they've taken a lot of the deficiencies of Puppet and Chef and considered that when they've gone and written something from scratch. So CF Engine has been around for a long time. If I'm correct, even before Puppet, Chef, Ansible was one of the first ones. It's written in C, but I haven't come across many people that still use it. It's probably good performance-wise, but there's just not a lot of stuff out there. And there's probably just not many people that want to have to write, C to deal with their modules when they can write Ruby or Python. So, build management software. So who's used some form of build management software here in their time? Yeah, cool. Any examples of what you're currently using, just out of interest?
I'm not using it at the moment.
No? What have you used in the past?
I've built one.
Okay.
And I've also looked at cruise control
Yep.
and Jenkins.
Yep, cool. Okay, any others?
Cruise control many years ago, and
Yep.
Jenkins at the moment.
Yep, cool. Okay. So, yeah, you probably know the purpose. Provide some kind of central interface to manage tasks or whatever and either execute them on a schedule or execute them manually or execute them on a code commit. That process could be a build, it could be a deploy of some code, it could be anything. Normally it'll provide a lot of input configuration, you can parameterize the input, it just provides your web interface wrapper around half this stuff. The good thing is if they start failing, you can use plugins to say email people, tell them their builds are failing. You can, after a build's complete, run some test suites. You can, do everything you want to do. So being able to track the history of everything and the console output of any of those tasks is obviously handy as well. When something breaks and you need to go and find a log, it's all just in the web interface, away you go. So Jenkins, as by the sounds of it, a few of you have used. Open source. Forked from Hudson. I was under the impression, until I did a little bit of research, that it was effectively they just moved across, but it looks like it was forked when Oracle decided they wanted to own it. So Oracle apparently kept developing Hudson internally. And then the open source world went and took Jenkins, the non-trademarked name, and continued development. And by the looks of it, no one's using Hudson and everyone's using Jenkins. Go figure. That's what happens when Oracle buys things. So, Yeah. The approach is less structured. You've got jobs. They contain build steps. You can reference a source code repository, and you can have job dependencies. So an example might be one job will be to build your project. Sometimes you even have to split it into multiple jobs to build different parts of your project. I guess one of the advantages, I assume some of you may have used different build slaves. Has anyone used Jenkins with build slaves? Okay. Yep. Okay. So you can in our current Jenkins use case, we've got 20 odd slaves hanging off it, 20 or 30 slaves. Some of them are Windows, some of them are Linux, some of them are Mac.
Does that work pretty well for you on Jenkins?
It's okay. It's not perfect. It depends on, and it's not always the same thing that breaks it. But a perfect example is Unity builds. If you can't really do Unity builds feasibly on Linux, but you may be able to build everything else on Linux. So we may have to run Linux build slaves to do parts of the application, and then we might have to run Mac machines or Windows machines to build other parts of the application that have a Unity dependency. So the fun thing is you normally have to treat those machines a little bit like pets and install the Unity license codes manually and do things like that. You can't just spin them up on the fly and use them. One of the really good use cases of Bamboo, which I'll go into in a minute, is they have a feature called Elastic Bamboo, where based on the size of the queue of jobs, they can spin up more slaves to handle that job workload, and then when those slaves are idle, they can spin them down. So you're only paying for the ones you're using. So if you get 10 builds all queued up, you spin up 5 build slaves, and it just does it for you. You don't even think about it. Problem is, you need the machines to be imaged. You need to not have to think about the licensing aspects and whatever else. So there's caveats around doing it. So Jenkins is less structured. It's very basic. You have jobs. You can categorize them, I guess. But you might have one job or a couple of jobs that build different parts of the project. There may be a parent job that says when all these child jobs are finished, the parent project's finished, and then you might say run some kind of test suite on them. Or you could even do the test suites as a different build step within the underlying jobs. So it's flexible. It's very flexible, but there's very little structure to it.
The dependency system is pretty painful. But we have a
Yes.
code build, and we have lots of jobs, but we generally structure it as a code build and then a Unity project build.
Yep,
but
that's right.
The linkage between the dependency between them is just really fuzzy and really brutal.
That gets really fun when you try and do 4 different output platforms for Unity. Plus servers, and then try and work with, for example, Perforce streams. Watch your matrix explode. But it has its place. It's less structured. It's very flexible. There's not much you can't do with it. It's just sometimes it can be painful because it's less structured in trying to. You got to come up with a workflow yourself half the time. So an alternative that's been around for a while now is called Bamboo, written by the Atlassian guys that wrote Jira and Confluence and everything. So Bamboo, I think they're both Java-based in some way. When you run a server, you're starting something Java-based. I'm pretty sure they've got like a Tomcat or something web server, Jetty, I think some of it runs on or whatever. But it's commercial. You normally you don't pay per user using it, you pay per build agent. So I think you can get like a license with like 1 build agent for almost nothing. I think as soon as you go like 2 or more build agents, it's a couple of $100 perpetual. They do have an on-demand version, like a hosted Bamboo, so you just pay them a monthly fee of a couple of dollars. You've got both options, run your own or that. One of the they both, like Bamboo and Jenkins both support build slaves. You can run a build slave. It's just a Java app that you can run. So you can run it on Windows, Mac, Linux, doesn't matter. And any of those slaves can execute any kind of task that, start, make, CMake, whatever, build tool you're running, you can call it. There's a million that you can pick from. But the good thing is it gives you a web interface to configure all that. You can clone jobs, so the workflow can be cloned. You can do all of that stuff. So
can you host this on your local?
You can. Bamboo, they'll let you download it and host it. And they do like a trial, like 15 or 30 days, and then you can you pay. I think you pay perpetually, and then there's like an annual support for like 20% of the perpetual cost. And the main benefit is support and updates. I think they give you the first year of support included. So when they do major version releases, if you're still within the support range, you get it. So so you can see it's a little bit more structured. Build projects contain plans, plans contain stages, stages contain jobs, jobs contain tasks. And so each of those can contain one or more. By default, everything has one of, but yeah, you can come up with a whole big tree of things, and then you can clone at different levels, and yeah. So one of the really good things that version 5 brought in, everything was just a build project before. Now you can distinguish between builds and deploys. So when you build your package, the output of that package is normally a build artifact. Might just be a tarball. It could be a Unity 3D file, for example. If it was a Unity build, it could be anything. You can part of your builds could even be build something in Unity, run it through Xcode for an iOS build, spit out an IPA file. Yeah, spit out an IPA file. So yeah, different platforms, you can handle all different scenarios. Yeah. So the advantage with deploy projects is the history is all separated now, and they've gone and they've given the concept of an environment or a group of servers that are all part of one environment that you can put your application onto and run. It's sort of deemed first class within Bamboo 5. So whenever you have a build, you say deploy, and then you pick which environment you want to deploy to, and you can have auto deploys on build completion, always deploy this build to this environment for CI purposes. You got lots of possibilities there. So it's definitely more structured, but it doesn't sacrifice too much flexibility. You are kind of forced to follow parts of their workflow though. So you sort of have to adapt a little rather than come up with your own. But the advantage is you don't have too much of the dependency hell that you get trying to do that in Jenkins and come up with your own workflow. They've kind of come up with one for you. So, yeah. Okay, automation tools. So I spend a little bit of my time dealing with build tools like I was talking about previously. I spend far, far more of my time on automation tools. So Jared would know about this tool very, very well by now. Yeah, good fun. So Vagrant. Has anyone heard of Vagrant? No? Okay. So yeah, from their website, create and configure lightweight, reproducible and portable development environments. So an example of how Vagrant would work, let's say you've got one person within an organization that knows how to configure the software stack and the dependencies on a server to get your application running. Then you've obviously got to get your code into that server and then run it. Now this would be predominantly a server-side application rather than a client-side application. It could also be that you're doing local development and there's a server-side component that is a dependency of that client application that you can't run the client without a server to talk to. If a developer wants to be able to work independently on their own and iterate on their own code, and they want to run a local copy of those servers, if you find that they'll only run on Linux, for example, there's some compiled binary that'll only run on one. Like most of the time you can make it work on Windows as well, but sometimes it's easier to run it on Linux. Then this is where Vagrant comes in really handy. A perfect example, part of our application stack is web-based, so it requires Nginx and PHP. We have a requirement for 64-bit integers in PHP, and there is no PHP build that runs on Windows with 64-bit integer support. So we're forced to run it on either Mac or Linux. So, and then when you've got an office full of Windows developers, what do you do to give people a local development environment? So hence, yeah, where we are today. So one of the real, let me just go. So yeah, Vagrant's been getting developed for a couple of years now. I think it was started by a guy, Mitchell, who lives over in California. The code base changes quite regularly. There's usually at least one release a month, sometimes two. It's usually bug fixes, improvements, things like that. I will bring up the websites shortly, just so you can see some of what the tools are capable of. The general goals are, you provide a developer with what's called a Vagrant file. Now, a Vagrant file will contain a an image for a like an operating system, for example, and then it can provide a host name, it can provide a network configuration, like what IP address to give the server when it starts up, and then you can run what they call provisioners. Actually, I'll go into this first. One of the good things is, I guess, you can give any developer that Vagrant file. They can download Vagrant off the website and just go into a terminal and go Vagrant up, and then it will look for the Vagrant file in the current directory and just start a virtual machine and do whatever the Vagrant file is telling Vagrant to do. So it's programmatic. It's really good for demos. I see a lot of systems online these days that someone wants to provide like a demo to people, and usually you'd go through a big, 2-page installation guide. They just provide a Vagrant file. And it's like, yeah, cool, just install Vagrant, Vagrant up, and you've got a copy of that application running in Vagrant within under 5 minutes. And they can play around and see it, and if they like it, then they set up a full instance and follow the proper guide. But they don't waste 3 hours of their day just to proof concept something they don't like. So that's where it's really, really useful. You can recreate them in 2 commands. If you don't have much provisioning work, you can, I think the destruction's like 30 seconds, if that, and the startup can be under 5 minutes. Can be. Everything in a Vagrant file is just Ruby. The things that you define, you define a box, which is an OS image. And when you define that box, you give it a URL to that box, and the first time it runs, if it doesn't have a cached copy, you go to the URL, fetch the image, and keep a copy locally. If you then destroy that machine and then up it again, you've got a copy of the image, it just reuses the cached one. So it just downloads it once. Which is really good, because then if a developer goes in, sets up a development environment. Let's say they go in and they break something in the system, and they're like, "Oh no, what have I done? I don't know my way around Linux very well." Just destroy it and up it again. It takes like a few minutes, easy. You got network settings. You can either do NAT, so the local machine can either provide like a NAT gateway to whatever network you're on for internet access, or you can bridge it and it gets DHCP off the network. You can specify what host names. Synced folders and provisioners I'll go into in more detail. So synced folders, maps a directory within the virtual machine to a folder on the host OS. So one of our use cases with Vagrant right now is we need to start the applications in Linux, but we don't need to develop them within that Linux machine. So we actually, let's say someone's got a checked out code repository on their Windows or their Mac machine. We then we put the Vagrant file inside that directory, and we use relative paths to then say, if you've done a build in Windows or Mac and you start Vagrant, you can start the servers and the code is just available via like it almost looks like a network drive within the machine, and it doesn't need anything special to do that. It's just available by default. So there's no dealing with copying files up to a server or deploying a build to it. It's just there. You just start it. So cool. Provisioners are quite handy. You can when you start the machine, start up a Vagrant file initially, first time, it will run all provisioners. Previously, up until about 6 months ago, every time you would start the machine, the provisioners would run. Now, they will only optionally run on future startup. So a workflow would be you do Vagrant up, you bring up the machine, the provisioners are run, you have a machine, you can now SSH into it and do stuff. You just type Vagrant SSH and you're in. If you want to shut the machine down but you don't want to destroy it, you get out of SSH and go Vagrant halt, and it will just halt the machine but not destroy it. If you want to destroy the machine, Vagrant destroy. If you want to bring back a whole new copy of that machine from a clean slate, Vagrant destroy and then Vagrant up. The good thing is if you go Vagrant up after you've halted, so you just shut it down, it'll just bring it back up, but it won't rerun the provisioners by default. If you specify a command line parameter, it will rerun them. It's not always necessary, it just depends what you're doing. The types of things you can run, there's a shell provisioner, so you could say on system startup, run this provisioner which goes and runs this shell script which does some stuff on the system. Or you can say run Puppet with these manifests. You can run Ansible, you can run Salt, you can run Chef. It can call all of them, just put it in. There's just some Ruby logic that you just follow and just go, yep, cool, away you go. So yeah, use case for DevOps. So we provide an entire local Linux environment, has everything configured the way someone needs to. They don't have to think about it. They just get the Vagrant, the Vagrant file's in the source code repository, so they just check out our source code repo. They install Vagrant straight off the website, and they just go Vagrant up, and away they go. A non-Linux user can do it with minimal prior knowledge. It's really good for cross-platform compatibility. And if a developer breaks it, they just destroy it and up it. Vagrant has, so there's provisioners. There's also a concept of what they call providers. Now, a provider is what virtualization stack to start the VM on. So Vagrant just provides like a common wrapper to the primary local tool is what they call VirtualBox. You can also provision to VMware Fusion, VMware Workstation. There are providers for Amazon Web Services. So you can say run a Vagrant file that spins up a remote VM. And then if you do destroy, it'll send the API calls to destroy the remote VM. So there are other providers as well, but that's just a couple of them. So the good thing is it's a common wrapper that deals with all the abstraction between the different types of virtualization stacks. So lessons learned. From using Vagrant for about 10 months now, provisioners are convenient but take time to execute. So this probably comes back to the point from earlier about pre-baking images versus running things on the fly. Currently, some of our provisioners, depending on how much internet bandwidth is available at the time, there's quite a lot of packages that get downloaded on the provisioning phase, can take us anywhere from 20 minutes to an hour. So the worst thing is if you go Vagrant destroy and then Vagrant up, you've lost an hour. The preferred mechanism is build the box with everything pre-run. So run the provisioner before it gets to Vagrant, which using a tool that I'll go into next. The advantage of that is I may run the box building tool on my machine, and then it might take me an hour, but it doesn't take everyone else an hour. Once the image is built, everyone else can start it in under 5 minutes. So
Is that built into Vagrant, or are you just giving people?
no, that's a tool called Packer.
Okay.
So VirtualBox integration can sometimes be buggy, very flaky. Half the time it's actually not Vagrant, it's VirtualBox. VirtualBox is a project that's sponsored by Oracle now. It gets version updates quite regularly. They do take bugs seriously, they do fix them, but half the time when something breaks, it's not actually Vagrant. And if it is, it's usually fixed within days. If it's VirtualBox, it could be weeks or months. Sometimes they have to go and put patches into Vagrant to work around bugs in VirtualBox. The people who wrote Vagrant then came up with another provider for VMware, and they opted to charge for it. I'm not sure what the motives were behind it all, but Vagrant itself is open source. The VMware provider is, there's a small price to it. But I've heard that the compatibility is far, far better. So, if you're using it regularly, you can, all you got to do is in your Vagrant file, you can just go provider, VirtualBox, provider, VMware, and it'll just look for the underlying installation and away it goes. So, so the next tool that I use is called Packer. Packer is written by the same author as Vagrant. He initially wrote Vagrant in Ruby. Since then, he's opted to, he maintains both actively now, and he jumps from each project. Spends about a week on one and a week on the other. Packer is actually written in Go. I'm not sure if any of you have heard of Go. It's a language that Google wrote internally. And it's a compiled language. It's statically typed, and I think they're trying to look for sort of C/C++ performance out of it. But I haven't written personally in Go to know the pros and cons, but I've actually seen quite a few projects that have popped up in Go these days. So, it's pretty much come right out of Google, and they've just open sourced the language, and they continue to use it actively internally. So, From what I heard last time, Google uses C++, I think Python, and Go as like primary internal languages. So for all the different systems. It hasn't been out quite as long as Vagrant, but it's being rapidly iterated on as well. So the goals of Packer, allow programmatic creation of images for any operating system. The first operating systems that were targeted were Linux. Since then, support has been increasing for Windows and Mac. I've only seen probably in the past 6 months, Windows actually starting to become something useful. So Packer actually, when it starts a machine up, it will SSH into it and run a handful of different things from within Packer. To go into a Windows machine, the problem is you don't normally have SSH. So I think they're trying to use, is it WinRM for remote access into Windows machines now? Which apparently, provides some kind of remote access mechanism. I haven't actually looked at it in detail, but it seems to work pretty well for them. So.
Is this redundant to Puppet?
So Packer can run provisioners just like Vagrant can, and you can run Puppet provisioners inside a Packer image. So the workflow with Packer would be, I'll actually show you, I've got some Packer runs on my machine from yesterday, and I'll show you the log output to see what it's doing.
It's like pre-building VM rather than just using a stock VM and then configuring it.
Ahead of time, just in time. Yep. So this would be the equivalent of building your machine, like taking a vanilla image. So Packer takes a source image. I tend to prefer to take just the vanilla OS image from wherever and then put everything on top programmatically.
So the part Packer's handling is basically doing the work of making the image for you from your Puppet stuff.
Correct. So it could be run a shell script, run Puppet, run Chef, run Ansible, run Salt, anything. And you can do multiple of those in order if you need to. You do whatever your workflow requires, Packer will deal with it. Packer deals with, Packer also has providers, just like Vagrant does. So you can do, I think you can do OpenStack, you can do Amazon, you can do Google Compute, you can do DigitalOcean, you can do VirtualBox, you can do VMware. There's about 10 common providers. You try and provide equivalent functionality across them wherever you can. So sometimes all the quirky stuff is when you spin up a machine, you need some kind of initial login credentials to get into the machine to start executing stuff. So Packer tries to make all of that invisible to you. Has like a local administrator account ready to go. Like they use some interesting mechanisms to get into a machine once it's started up, and then away it goes. Parallels is actually another one that they support in Packer, which is quite handy if you're running Parallels on like a Mac. So the Packer workflow. You provide a JSON file containing the builders, the provisioners, and optionally post processors.
It's not Ruby.
It's not Ruby. No. So it's written in Go and the actual application, and it's compiled, but the input is a JSON file. Yep. So you can contain multiple builders in a single JSON file, all running concurrent threads. So the example there is a very good one of what I do right now. So effectively, Amazon will have like 8 different regions around the world with data centers. PV and HVM is basically para-virtualized versus hardware virtualized. And they have different types of servers that you can run different types of Amazon machines on. And then they have different underlying storage. One of them is called Instant Store, and the other one's called EBS. EBS is more like a network storage within their network. Instant Store only exists as long as the machine is running for, so they call it ephemeral storage. So you spin up the machine. If Instant Store is local disk, it's all solid state, and it's very, very quick. The problem is when you shut the machine down, it's gone. So one workflow that I have tried to adopt now with Amazon is if you can get away with eventual consistency at all, flush to Instant Store disk and then sync to EBS or sync to S3 after the fact, because you'll find it is quicker to write to Instant Store disk than anywhere else initially, but then it's not persistent. So you need to then trickle it off to one of the other two. EBS, the problem with it is once every 12 months they decide to have a major outage that affects everyone using EBS in one region. Tends to be the thing they do about once every 12 months. But over time it'll get better, but Instant Store is obviously local to the system. So unless the VM dies, chances are the Instant Store disk will survive. Whereas the network storage, it'll affect all your VMs in a given region. So EBS is also, because it's network storage, it's nowhere near as quick as Instant Store disk. But it's, you can make it faster at quite a cost using provisioned IOPS and all kinds of things that they put in place to do it. But you still can't beat the performance of the local disks. So what I do is I have all my scripts and I go, I want to build these images I want to build all 4 types in all 8 regions. Packer actually has an ability to say build the image once in one region and then behind the scenes copy it to all the other regions. It's actually quicker to build a new one in another region than it is to transfer the image from the old region. So, and I benchmarked it. It was taking me, I build 4 versions of Ruby in parallel from source in my Packer builds right now, just the way that I'm doing it. And it's a whole system spin up with all the base packages that I want to be installed everywhere. It takes me 18 minutes to do all of them. It takes an hour to copy an image from one region to another. So it's quicker for me to build 32 of them in parallel because they all finish in 18 minutes versus wait an hour. So, iterate the same way that you do writing software. Modify it, test it, review the output, repeat. It's pretty much, infrastructure as code. So, Packer provisioners, the meat of what Packer can do to an operating system. Same as what you can do with Vagrant. The downside is with Vagrant, obviously, if everyone wants to run it, it's just in time, and it can take everyone quite a while to do it. With Packer, you can do it once as an image, and then whenever someone starts that image up, all the provisioners have been pre-run. So they don't have to build it at runtime, it's pre-built. So costs me a lot more time, but it means that everyone else saves a lot of time because of it. So, and it's, something that I've realized if you can do that, do it. All the provisioners are executed in order. You can, do all the same type of stuff as Vagrant. Lessons learned, still in rapid development. I have had some interesting weird problems with SSH access in the past, where they had thread problems when I exceed about 8 builders. They would get all kinds of weird stuff going on. That seems to have gone away recently, but it can happen. They're adding providers all the time, like almost once every month or two there's a new provider coming out for some new virtualization system. The good thing is if there's some configuration management software that isn't a provider, you can always have a shell script that installs that on the system and then runs it locally anyway. So you're not bound to only the configuration management systems they have. You can always just go off and do it yourself in a shell script and just execute that instead. So, the VirtualBox builder is fun. It's taken me best part of 2 solid days to get it to work from examples on the net, but I finally got it working yesterday, which I'm happy with. Meaning I can now make a Vagrant box with Packer with the only input being the Ubuntu ISO off the website. And it will go and build it. You have to install the VirtualBox guest edition, so there's extra kernel drivers for the local system and stuff like that to make Linux run cleanly within VirtualBox. And then, there's a lot of little weird things that I had to set up, and I can even show you some of the scripts, but I think it takes, it's really quite interesting to watch Packer install an operating system from an ISO in VirtualBox, because it will actually load up the VirtualBox GUI and start typing commands in, and it will do an unattended installation, and it will answer all of the questions using like a PXE boot setup. It sets up a web server locally on its own little bridge network, and then makes that machine go DHCP and use PXE to go and get a configuration off it, and then go and tells it how to install Ubuntu. Then it does everything, and then it'll even handle reboots, where if you tell a provisioner to reboot, the next provisioner will start after the reboot in the cycle. So you can do 2 or 3 reboots in the process of building an image. So you can, it's quite intelligent there. One thing that's really handy is, the AWS builders are really good, with the exception of the SSH problem I had. They work really well. Just you give it all the Amazon API keys, and it just goes off and talks to Amazon and spins up machines. Layered image creation can work really effectively. So an example would be, we try to have machines that are, we have certain packages that we install on every system. Traceroute. There's a tool called ATOP, which just lets us measure like system performance, like CPU, RAM, and stuff like that. There's probably 20 or 30 tools that we install on every system, just so they're there for diagnostics purposes. So what we do is we do one packer run where we take the vanilla OS image, install those tools on it, and then spit out another image. Then what we do is we go, okay, after that we have roles, like 10 or 15 roles, where this machine is going to be a machine that runs a message bus. This machine is going to be a web server. This machine is going to be a MySQL server. This one's going to be a MongoDB server. This one's going to be a Memcache server. All these different server types. So what we do, we haven't done this yet, but we're going to shortly. Take the result of the first run, feed it back into Packer, and run different builders with different provisioners for each, and then effectively spit out role-specific images underneath that. And then from there, we can spin up as one or more of those role-specific ones, and everything is just in time. Right now, we only do the first stage, and then we run Puppet provisioners on boot for the next, for the role-based stuff. So it's really a balance of being able to iterate quickly and just, like when I'm making changes to those provisioners actively, I'll just run the provisioners and then, look at the results. If I want to spin up lots of copies of an image and I know that the provisioners are doing the right thing underneath, then I'll just, I'll actually build the images and then, just run them. A perfect example of where that's useful is, Vagrant. So, if I wanted to have one VM with everything on it, I could build one box. Or if I wanted to have multiple VMs, one Vagrant file can actually, you can specify multiple VMs and it will start them all in parallel on the same local network inside VirtualBox. And you can give it all kinds of weird network topologies, bridge network, private network, everything. You might have role-specific VMs, and you'll say this VM is this box, this one is this box, this one is this one, and they'll just go off on their way. So that's with Vagrant. If you're using someone like Amazon and you want to go and auto-scale your application, the key to auto-scaling and following that demand curve, there's 2 components. One of them is smaller increments are better. If you've got a curve like this, you don't want to be going dirt, 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 dirt. You want to be going dirt, 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 because you have smaller machines but more of them. The downside is the smaller machines tend to have performance implications compared to using the single large machines. You've got to come up with a bit of a balance there, especially in Amazon. The other component is when you spin a machine up, how quickly from when you say start, is that machine ready to start taking part of your workload? So if it has to run a heap of provisioners on startup and it takes it 10 minutes, say, to before that machine can do it, depends on how quickly your curve changes. You can't hug the demand curve as quickly because you'll have increase the number of servers and then 10-minute delay, and then server gets added to a pool and it starts taking some kind of requests. If all the stuff is done ahead of time in the image, that might be 2 minutes or 3 minutes. So it doesn't have all that ramp up every time it starts a copy of that image. So you've got to balance initial development of it. It's better to do it where you run the provisioners just in time, I guess. And then, when you're actually going to auto scale and you want to shrink that time from start to in a cluster, then doing it ahead of time makes a lot more sense. The other thing is versioned images. Can allow easy rollbacks. So we can just build as many copies of these images as we want, and I've just written a Ruby script that goes and interrogates Amazon's APIs and gives me a list of all of them, and they're all time-stamped, and it just says delete all but the most recent, and they're just all ticked, and I can plus and minus them and just go confirm, and it just sends a delete call to all of them. So you just basically come up with a cleanup process. So, but there's no real downside to me keeping as many of these images as I want. They probably cost a couple in the cents per month each range to have these images laying around. So I only need to do it when, we got 50 images laying around. I just go, I might just clean it up because it's, getting messy. So, yeah. Docker is another tool that is even more recent again. It's starting to gain popularity. Their whole concept is around, they try to use the analogy of virtual machines are like shipping containers. The world of shipping came up with a standardized size 20-ton equivalent unit shipping container that could fit on every ship, had the same dimensions, and they could just drop it on the ship and dock it on, and it just interlocks. And then you've got all these large ships these days that can do it. The idea with Docker was that you could have a single image format with certain settings that are bundled with it, where you build the image. Packer can actually output Docker images. The idea is a Docker image can run inside any other operating system, and an example is they're a very lightweight container. So an example might be if you've got a build, instead of having a build artifact of a tarball with your software, your build artifact might be a Docker image with everything sitting inside it. And you could have software dependencies, your application code pre-built, everything like that.
So is it an image for a single app?
Normally that's what you could have it, yeah. So if you had different components to your app, you could have different Docker images for different parts of it, or you could have one Docker image for everything. Just depends on your workflow.
And that allows you to plug it into any virtual machine?
You can take any of those, any machine that has Docker running on it. I think it's predominantly Linux machines though, and Docker really only focuses on Linux VMs. So it has a place, but personally I don't think it's everywhere. So
I've had a bit of a very brief look. I wonder if somebody might start doing a platform as a service type thing.
And use Docker, yes, and you just upload your Docker image to it. Yeah, that might make a bit of sense. Yeah. Right now, so they're lightweight Linux containers. You just like you distribute a binary build, you just distribute the Docker image. The good thing is it's a known content, so once whatever the contents of that image is, it's the same everywhere. So all the dependencies, everything, whatever works on it should work everywhere. I personally don't think it's the best for. I believe it's best for non-virtualized environments, like physical servers would make perfect sense, because you don't have a virtualization stack and you can just run as many Docker images as you want. They're lightweight. They don't have the overhead of a VM. Sometimes you'll lose 10 or 20% of the resources, depending on the virtualization system you're using. So you can do the equivalent functionality with AMIs, which are Amazon Machine Images, on AWS. And so in most cloud providers, using Docker would be 2 layers of abstraction. You'd spin up an AMI, which has very little in it, and then you'd put a Docker image inside that and then start it. It just feels kind of redundant when you can just build the AMI with everything in it in the first place. The downside is it would be provider specific, that AMI. You would lose the portability, whereas Docker, you could just go and drop the image on anywhere and that same image would run. So you could run that image locally, you could run that image on any other Linux machine anywhere in the world. So with Packer, on the other hand, I can just build as many images as I want. I can build a VirtualBox image and an Amazon image at the same time in different threads. So it kind of, at least for my use case, it defeats the purpose. But I think it has a place, but it's just not everywhere.
One place I can imagine it being used is you were talking about the thing where it was build versus copy for your different zones. So I imagine that if you built a Docker,
you could build the Docker image and then transfer it.
It'd be way smaller, right?
That's the theory, yeah, because they're only a lightweight container. They're not meant to be the entire operating system. So, I think that's a valid use case. Yeah, what you could do is you could build a Docker image and put it in S3. Which is their Amazon object storage. You drop that there, a couple of 100 meg, and then whenever you start a machine, you just pull it off S3 and start it. That'd be one workflow. Yeah, cool. Any questions? I don't actually know how long I went for. Oh, what do you know? I actually did go for a while.
Thanks, Nathan.
That's all right.
Thanks to Jared for putting us in touch with Nathan.